Hello everyone, my name is Anisha. I am currently pursuing Information Science Engineering at NIT Meenakshi Institute of Technology. As a part of Samsung Innovation Campus program, I have chosen the problem statement Vehicle Damage Assessment as my capstone project. So let me give a brief introduction about my application. So imagine a city like Bangalore where hundreds of accidents that will be happening all across the cities, and it will be very difficult for inspectors and insurance officers to analyze and go through all the images and inspect on it whether it's damaged or like what happened. And different people will have different opinion, like whether it's minor damage or major damage, and they need to verify whether it really eligible to get the insurance claim report or not. So I have built this application using ML model so that it will be easy for the assessment. So let me go through the ML model code. This part indicates I want to tell that I have used the data set from the Kaggle, which has two classification, damage and not damage, and I have uploaded the data set in Google Drive, which is connected to Google Colab, and the data set is stored in the local storage so that it will be easy for it to access and train the model. And then as we can see here, data set is extracted successfully. And then I wanted to make sure that I'm on the right path and the collab is accessing the right file. So I have just printed the root directory file. As we can see here inside the data set, there are training and validation file, which has two classification, damage and not damage. And these are the two files present inside the data set. These are the two classes present inside each file. Before training the model, I wanted to make sure that the data set is balanced. So as we can see here, the number of images in each classes in for training and validation, it is same. So that my model is not be biased to one particular class and predict inaccurately. So I have made sure that the data set is balanced. Same goes for validation as well. And then I have just printed the visualization of the data set. So whatever the image data set that I have used, I've just printed it. And then before training the model, I would like to tell that for this ML model, for this application, I have used CNN pipeline ResNet, which is relatively best for image classification, for binary classification. So ResNet is already being trained on millions of images on ImageNet. So I've used that because it already knows the features, edges, curves, and also it need not to learn from the scratch. What I just need to do is replace the final classification layer so we get the expected output as we want. So ResNet is already been trained on image of particular size. So I want to make sure that whatever the data set or the images that I will be using for training, it will be of that particular size. So I have to resize it for training the ResNet model. So I've printed the image size of my model. This is 259 into 194 for damage, and for not damage, which is whole, it is 550 into 312. And for training the ResNet model, I have used PyTorch, and these are the libraries that I have imported: datasets, transforms, data loader, which will see it further. And as we can see here, by using transforms, I have used resizing so that my data set is resized to 224 into 224, which is the mean, or like which is the image size in which the ResNet is being trained. And then used a random horizontal flip where training is the images inside the training is randomly rotated in horizontal or vertical, so that my model should not predict on one particular angle or in one particular direction. In whichever the angle the user takes the picture, it should be able to identify, analyze the picture and predict accurately. So random rotation is there, normalization. These are the numerical distribution in which the ResNet is being trained. So I'm just converting my image dataset into these particular statistical values. Same goes for validation dataset as well. And here transform is done, and here is the dataset. library. So as we can see here, I have chosen my path for the training and validation. And I've loaded the dataset by using their path, verifying the dataset, and then data loader. So my model is not being trained for all the dataset all at once. So it will be trained in batches. So that batch size is here 32. As we can see, batch size is 32. That's how it will be trained in batch size. So verifying the data loader here as well. And then again visualizing the batches of images. As we can see here, these are the sample images that we will be training for the model. Damage it is, hole, etc. And then model, now comes the main part where I will be importing those pre-trained model, which is ResNet, and its weight, so that whatever it's learned, it should be helpful for the model prediction. And then inspecting the model. And here I have printed that I have used GPU Tesla T4 in the Google Colab. And for the optimizer, I have used Adam optimizer, and learning rate is 0.001. So what if it makes any error, so that it learns and update its value, which is done by Adam optimizer. And here comes the training the CNN model, which is ResNet. And I have run the epochs, and as we can see here, the accuracy is being increased till the end. And here is the model evaluation. As we can see here, I got the accuracy of 94.57%, and I have printed the classification matrix as well, performance matrix, including the classification reports. As we can see here, for the precision, recall, and for each classes, it is being stabilized 95, in the range of 90 to 95 only. And these are the confusion matrix. And I've also plotted the graph for training versus validation loss. As we can see here, except for the one, the loss is being reduced from the first to last epochs. Same goes for accuracy as well. From low to, it is being increased to high. And I've also plotted the ROC curve, as we can see here. And the ROC curve AUC value is 0.98, which is approximately very close to 1, and this tells that my model is a good fit. And this is a precision and recall curve. These are again the visualizations. And then saving my model as this vehicle damage ResNet path, so that it will be easy to access for the front end rather than calling the model again and again, which will take time. And model is loaded successfully. And this is just a sample output that I have taken the internet image path of one image from internet, and it has correctly predicted, which is output damage. Let us just go through the front end part. This is the training model code. As we can see here, so model is saved as vehicle damage assessment path. You can see here it is a vehicle damage model path. That is only what we have used. And this app.py gives all the front end code. So now let me just show the demo of my model. So this is the home page. This is how it looks. AI assistant is there, history is there, and then bilingual feature is there, and then themes is also there. So let us see. I will just take a random image and just upload any one of the images. Upload it, and then run assessment. It is analyzing the image, and as we can see, it has accurately predicted that it is damaged, and it has given the small summary that based on the description of the images, it is analyzed, and based on the damage, we can see whether it is eligible or not. So I've just added this assess insurance claim readiness. So here you just need to put on whether it's the accident is done because of third party or the own damage or not, and then you have to click whether you have the valid driving license or not, and then I'll just click for the negative thing, and I don't have a valid driving license. I have not filed any FIR complaint for the accident. And that suppose the accident is has occurred before the 30, or like it's been 30 days for the accident that has happened. So let us see what it will predict. Calculate the eligibility score. It is given 30 by 100, like it is a high risk, or potentially it is ineligible to get the insurance claim for this damage. Then if I want to, suppose if it is really eligible, we can directly print or take the PDF of the insurance claim. Let me just give the input. Then policy number, inspection ID, some remarks, and download PDF. As we can see here, it has printed the damaged part, including the image, including that it is classified as damaged, and including all the input details. And if we directly want to print it, that is also an option there. Just print. So you can directly print this insurance claim and submit it to the insurance office. So that is all about my model. Thank you.